This is a hard question from the abstract reasoning and the UCAT. It involves quite a lot of different tools to answer. That includes counting, understanding positions of shapes, and if you encounter a question such as this one that's quite hard in the UCAT, I recommend skipping it and saving it for the end because you only get only so much time whilst doing the test. But if you can spot the pattern straight away, that's great. I'll give you a moment now to just look at the question yourself and try and figure it out. So just a little hint, you can pause after, and that is when you see four shapes that are in either a plus shape, such as here, or a cross shape, such as here. It might be useful to draw out a little compass, like I've done over here, as they really like to incorporate the north, east, south, or west into answers within the abstract reasoning question. So that's just something to jot down on the side as one of the more powerful tools when answering abstract reasoning questions. If you'd like to have a little bit more time to answer the question, you can do that now. Okay, first we're going to look at set A. Now we have first the plus configuration, so the north, east, south, west configuration. The first thing I noticed that whenever it is in a plus configuration, the north and south shapes have some sort of black element to it. A black shape inside a larger white shape or a black shape overall. There are black shading in the plus configuration. Next, to do a little bit of counting, if we look at north and south only, we have 1, 2, 3, 4 shapes in the plus configuration. Let's look at the second example. 1, 2, 3, 4, and finally 1, 2, 3, 4. And we see something similar with the east and west shapes. 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. So therefore we can conclude that in a plus configuration where we're dealing with north, east, south, and west, the north and south shapes will have some black element involved, and the north and south shapes equal 4 when you add all the shapes together, and so do adding the east and west shapes. And then for the cross configuration or the northeast, southeast, southwest, northwest configuration, there aren't any shaded in black shapes, but a similar counting pattern emerges if we look at the shapes in northeast and southwest. We can see that the number of shapes add up to 3. So we have 1, 2, 3, and again 1, 2, 3. And again, at the bottom left example, 1, 2, 3, 1, 2, 3. So that's the pattern for the cross configuration. Now for set B, again, when we have a plus configuration, we can see that the north and south shapes also have a black element involved. So as we can see here, black, 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 black. So that's one pattern we're seeing. And again, if we count, we can see that in a northeast southwest configuration we have 1, 2, 3, 4, 5 shapes when we're adding the north and south shapes together, and 1, 2, 3, 4, 5 shapes again when adding the east and west shapes together. And then looking at the cross configuration, we can see that there's no shading, but if you add the northeast and southwest shapes, like here at the bottom, you get 4. And if you add the southeast and northwest shapes, you also get 1, 2, 3, 4 shapes. And that gives us enough information to answer the question. As we can see here, we have a plus configuration, but when we look at the north and south shapes, we don't have any black coloring. Therefore, it goes against the rules of both set A and set B, so this shape would go into neither of the sets. Here we have a cross configuration, and if we do some counting, 1, 2, 3, 4, and 1, 2, 3, 4, we can see that this shape is following the rules that is found in set B, where the northeast and southwest and the northwest and southeast both add up to 4 shapes, so therefore the shape belongs to set B. And here we have another cross configuration, 1, 2, 3, 1, 2, 3, that follows the rules of set A, where northeast and southwest shapes add up to 3, and northwest and southeast shapes add up to 3. So as you can see, those two add up to 3, and those two add up to 3. Therefore, our answer is this shape belongs to set A. And just like the question we just did, we have a cross configuration where these two shapes add up to 3, and these two shapes also add up to 3. There's 3 shapes between each pair, so therefore we can conclude that this shape would belong to set A. Now again, a cross, but this time the diagonals, the shapes add up to 4, and this follows the rules of set B, so this shape would belong to set B. And here's the answer rationale for that question.